Hello everyone, welcome to Big Data Thoughts. Today we are going to talk about a very interesting and upcoming topic, which is quantum computing. It has been there for quite some time, but I just wanted to have one dedicated session talking about what it is, what are the key concepts, the why it was needed, what is the applicability, and finally where quantum computing is today. Is it like really evolved, or is it at a nascent stage where we are? So we'll talk all about that. Let's get started. First of all, let's talk about what was the need to have quantum computing. So as we all know, computers have actually eased our life a lot in terms of doing computations that are difficult for a human being to do manually. But there are certain problems which our traditional computers would not solve, and then the scientists and engineers would actually go with those difficult problems to a supercomputer. Now, there are certain problems which are even difficult for supercomputers to solve. Those are complex problems which have lot of variables which are interacting in a complicated way. And we'll just, in a few minutes, we'll look at what those problems are. But essentially, the problems that supercomputers also cannot solve, or which are very complicated for supercomputers as well, is where there was a need for quantum computing and people started to turn towards that. So that was the need. So, what are those special complicated problems that even supercomputers struggle with? Those are known as combinatorics, and these problems are where there are a number of variables which are communicating or which are interacting in a very complicated way. So, these kind of calculations actually involve finding out an arrangement of items that optimize some goal. So, if we are looking to achieve some goal and there are multiple options that can take you to that goal, doing that calculation or finding out the best permutation and combination to reach the goal can be really complicated. So as the number of items grow, the number of arrangements keep on growing. So if let's say we want to reach to a destination, so this is a simplistic example, but just to explain, if there is a destination we want to go to, and if there are n number of paths to reach there, as the number of paths increase, if the path become like, if there are billions of paths, then it becomes very impossible or complicated for even a supercomputer to calculate different permutations and combinations. So when the calculations involve these kind of arrangements to optimize to some goal and the number of arrangements increase, that is where the problem becomes complex. And today's digital computers, basically what they will do to find out this arrangement is they have to iterate through each and every permutation, find the outcome, and then identify which is the best one to achieve the goal. Now it may require an enormous number of calculations. This is known as combinatorics, this kind of a problem where the number of choices are too many, so this become hard even for supercomputers. Now, what is quantum computing? We looked at why it came into picture, what kind of problems actually gave rise to quantum computing. But simply, if we have to define quantum computing, what is it? It's a very rapidly emerging technology. It's not very at a very developed stage. It is still evolving, and it uses the laws of quantum mechanics to solve complicated problems which are difficult for classical computers. Just as the classical computers, when they came in, they reduced our effort and cost of arithmetic operations, quantum computers similarly do reduction in cost by calculating very complicated combinatoric problems. Quantum computing also refers to a computational technology which is based on the principles of quantum mechanics. And things like, there are some key concepts in quantum mechanics like entanglement, superimposition, inference. So it helps you to solve those kind of problems in complex situations and on huge amount of data. Now, when we are talking about quantum computing, we need to know a bit about what quantum world is or what quantum physics is, because quantum computing is based on the principles of quantum computing, quantum physics. Now, quantum computers are based on a completely different model of how the world works. If we look at classic physics, we will see that any object will always have one single well-defined state. But when we talk about quantum mechanics or quantum physics, the object can actually occur in multiple states. Okay, it will occur in one well defined state only after we observe it, but prior to our observation, the object can have multiple states. So the way the data here is recorded, stored, processed is very different than how traditional computers do. Because when we talk about our traditional computers, we talk about bits and bytes. So the state in which our classic computers lies either a 0 or a 1. And a combination of that 0 1 actually help is used in our computers. But when we talk about quantum computing, it works totally on something which is non-binary. It's not 0 and 1, because as I said, quantum mechanics object can exist in multiple states. So then that something that is used there is known as qubit, a qubit of information. These are not binary bits, and they are designed specifically for quantum world or quantum computing because they can reflect the multiplicity state in the quantum world. Now this multiplicity is complex, but it can enable faster and lower cost calculation for combinatoric problems. So any kind of combinatoric problems, complex problems that we were talking about, this kind of quantum computing with qubits would be much easier. So let us look at each of these terms, what they are. First of all, what is qubit? The fundamental unit, like for our classic computers, it is a bit, which is either a 0 or a 1, binary, but here the lowest level or the basic building block is qubit. Now this qubit represents quantum mechanical system which can take up different quantum values. So it can scale exponentially beyond the conventional ones and zeros. So if it is a 2 qubit system, actually it can do 4 concurrent computations. If it is a 3 qubit system, it can do 8 concurrent computations. Similarly, 4 qubit can do 16 concurrent computations. So basically qubit is the most fundamental unit which can help in representing multiple states that are present in quantum physics. The second key concept to understand is superposition. What does superposition mean? Superposition implies that in a quantum system can have different states at the same time. So superposition is an ability of a quantum system to have multiple states until it is measured. So when we observe an object, we will get one defined state, but before we do that observation, it can have multiple states. For example, when we toss a coin, if the coin falls on the ground, we will see either a head or a tail, which is pretty similar to having a binary state of 0 or 1, as in classic computers. But while the coin is in the air before it falls to the ground, it can have multiple states which is not yet defined. So that is actually something that we can relate to having multiple states before an observation is made. So this kind of a property which where you there is a capability of the system to have different states at the same time, that is known as superposition, and this is one of the fundamental building blocks of quantum mechanics. The other thing is entanglement. What does entanglement means? It means that if we entangle two or more qubits by establishing some correlation between them, that is known as entanglement. We are entangling two or more qubits by establishing some correlation between them. So if there are two qubits which are tangled and we make change to any one of the qubits, it will impact the other without exception because they are entangled together. Quantum computing algorithms use quantum entanglement for faster data processing. So superposition and entanglement are very fundamental concepts to a quantum mechanics, and this is what is used when we talk about quantum computing. Now other important thing is, what are the applications of quantum computing? So the first application of quantum computing is in the field of deep learning and machine learning. These kind of algorithms that we use today for deep learning and machine learning can actually be optimized by using quantum computing, because they combine the classical and quantum simulations to solve problems. They are far better or better suited to solve complex problems, so they can be used to optimize deep learning and machine learning algorithms. Another usage can be drug development. So quantum computing is crucial in the drug development, because for testing any kind of molecular configuration using a molecular modeling process where the electrons are actually moving in a speed where they can have multiple states, it is easier to model them using quantum computing. So it speeds up the drug development process and makes it much better to assess the molecular configuration. It can run advanced simulations on various organic molecules. So that way it helps in the drug development. Another thing is model chemical processes. So quantum based simulations can be used for modeling very complex chemical processes and atomic interactions. They are much faster than the traditional methods of experimentation, which will have errors as well. So these kind of chemical processes which require simulations, quantum computing can be used. Then in the finance field, to do financial trading, stock portfolio management, quantum computing can actually be used instead of the traditional algorithms which are not that time sensitive or poor in time sensitiveness. Similarly, the development of climate models. Quantum computing can be used to stimulate the very minutest detail of wind, temperature, humidity, pressure, etc., and do a better model to predict climatic conditions. So there are many applications of quantum computing that can be there. These are just few of them. But then what we need to understand is that quantum computing is not that widely used till today. It's still in its infancy stage, and they are available for specific requirements. Like quantum computing is still evolving, and the reason being they have their own specific requirements about hardware, temperature conditions, the way they are built, these kind of computers. So it is costly and it's still not that prevalent, but there are multiple government organizations, companies, etc., who are experimenting and investing into quantum computing. So in the coming years we may really see that growth, but as of now it's still evolving or emerging. Yeah, so I think that's all for today, and a brief introduction to what quantum computing is. I hope it has given you a perspective into what it is. So please share, like, and subscribe to the channel to get more interesting videos. Thank you so much.